Hello and welcome back to Miles Maths. Today we're going to be looking at completing the square, and particularly about completing the square to find the turning point of a quadratic. In order to complete this successfully, you should be conversant with being able to complete the square at a basic level, although we will go over that in some detail today. And you should be familiar with the graph of y equals x squared and other quadratic curves. We'll jump in straight away with an example. You will need to take notes on this and write this down. So EG1, we're going to look for the turning point of y equals x squared plus 8x plus 9. So the turning point is just the coordinates of where the quadratic, where that point right there is the minimum point, also known as the turning point. What we want to know is where is the location of that point? What are the coordinates of that point? So in order to do this, we're just going to complete the square, and we're going to stick to the standard rules of completing the square. And that is to say, we're going to take this number here, this 8, and we're going to divide that by 2, and we're going to get 4. And we're going to call this x plus 4, and we're going to have all of that squared. So this is our standard method for doing this, is to divide that by 2. We then leave the plus 9 on the end of the equation, but we have to apply a correction factor. If you haven't done this before, then there is another video on Miles Maths about doing this particular thing. And we have to apply a correction factor, and the correction factor, which goes here, we take whatever number we have there, which is a 4, and we square it and we subtract it. So we square it and subtract. And 4 squared is 16, so we're going to take off 16. And there it is. And then we can write down our final equation. So we have x plus 4 all squared, and 9 take away 16 is minus 7. So this we call completed square form. And completed square form is very useful. It's very useful for a number of things, but particularly for finding the location of this point here. And the reason, the way we find the location of the minimum point is by saying, well, if I take that 4, it's a plus 4, so I'm going to make that negative. And this minus 7, well, I'm just going to keep that as a minus 7. And my turning point is therefore at minus 4 minus 7, and this works every single time. So I change the sign of the number in brackets, make that a negative if it's positive, and a positive if it's negative. But the number on the end, the minus 7, I just take as itself, and that's the location of the turning point. Now this would allow me to sketch the graph if I wanted to. So as I say, this is a sketch, and you'll remember with sketches we're not being in any way accurate. Don't regard the grid as anything other than just a guide. And we have x and we have y. I know the turning point is minus 4 minus 7, or minus 4 minus 7 might be down here somewhere. I can note that point. I can also note that from the original equation that we cross the axis at plus 9, so plus 9 might be up here somewhere, and I would then therefore know that my graph looks something like this, and not the greatest sketch of a quadratic of all time. However, we know it looks something like that. So that's our first example. So let's try a second one, and you can follow this and you can have a go as well. we're going to consider the example y equals x squared minus 6x plus 14. Can you, following this method, go and produce a sketch? Well, firstly, find the turning point of y equals x squared minus 6x plus 14, and then draw a little sketch of what the curve looks like. Stop the video now. Okay, let's assume you've done that and you're back. We'll just have a quick look through this. We'll do this exactly the same way we did the previous one. First thing is I need something in brackets here, and the way I find that is I take that number and I divide it by 2. This gives me minus 3. So this is x minus 3 squared. I still have my plus 14 on the end. I then take my minus 3 and I square my minus 3 and I take it away. Minus 3 squared is 9, so I'm going to take away 9. And there's my take away 9 on the end, and that just comes from square it and subtract. And that's all I'm doing. So my completed square form is going to be x minus 3 all squared, and 14 take away 9 is 5. So what I can say therefore is, turning point is going to be 3, 5. And you'll notice once again that I have taken that minus 3 and I've changed the sign to produce that 3, and there's the 5. If I wanted therefore to sketch this, I could do this quite quickly. Here's my axes, x, y. I know my turning point is at 3, 5, so it's somewhere up here. Let's put 3, 5 as there. I know that it goes through 14 on the axis, so it's here somewhere, and therefore I could just draw a quadratic coming in like that, and we'd label this as being the point 3, 5. And we might put 14 on that axis. Equally, we could have put 9 on that one, just to show where it crosses the axis. It's as easy as that. What we're going to do now is we're going to do 2 further examples, but we're just going to look at examples where the coefficient of x squared is not 1 as it is here. And we're just going to remind you how to do that very, very quickly. So EG3 is going to be y equals 2x squared minus 16x plus 19. With these, completing the squares slightly different. The method, slight change in method. Different teachers will teach this slightly different ways. However, the way I've always taught it is to do a part factorisation of this section. So we do a part factorisation of this first, and just get that 2 outside a bracket like that. We can just leave our plus 19 sitting on the end. This means that we can complete the square now in here, but we have to remember when we produce our correction factor, we have to double it because there's a 2 outside the bracket. This method works very well because it also works for negatives. Where you have a negative x squared on the front. So we can just say 2, and now we'll complete the square in here. X squared minus 8 just becomes x minus 4 all squared. I then have to take my correction factor. Obviously I've just halved the 8 to get the 4, as we did in the previous examples. I'm now going to take my minus 4, I'm going to square it. So minus 4 squared is 16. I'm going to double the 16 and get 32. So I have to take that away. So I have to take away 32. So this gives me 2 x minus 4 all squared. What did I say that was? Minus 13. I'm going mad in my old age. So once again, the turning point here is going to be 4 from the -4, and the -13 just stays as it is. And there's my turning point. And I could go and sketch this in much the same way I've sketched the others if I wanted to. So we'll do that very quickly. So my turning point's at 4 minus 13. So 4 minus 13 is right down here somewhere. We know that it crosses the axis at 19. That's right up here somewhere. And so I can just sketch that in. And it's quite a narrow quadratic. It looks something like that. Great. So here's EG4. EG4 is for you. Can you have a go at doing the same thing with y equals 2x squared plus 12x plus 23? Stop the video now, find the turning point, sketch the graph. I'll give you a couple of seconds. Okay, let's assume that you're now back. We should now have 2x squared plus 6x plus 23. This is the part factorisation. We then complete the square. X plus 3 all squared, because I'm halving the 6 to get the 3. I've got plus 23. I now have to make my correction. 3 squared is 9. Doubled is 18, and I need to take that away. This will give me a final answer of 2. X plus 3 all squared. You'll notice I don't need the double bracket, the square brackets anymore. And 23 take away 18 is 5. And this gives me a turning point of -3, 5. And my sketch would look, well, my turning point's at -3, 5, -3, oops, -3, 5. My turning point would be up here somewhere. I know it goes through 23 on the y-axis. There's my y-intercept, and therefore my sketch would look something like that. Sketches don't have to be very exact. They don't have to be exact at all. And so that ties together how we would find the turning points of these graphs. Now, there are certain questions that we might be asked about these graphs. We'll come to those in later videos. However, for example, you can see that this graph here has 2 solutions. It crosses the axis in 2 places. This graph here, this equation here, has no solutions. It doesn't cross the x-axis. So there are certain applications to this that you'll need to come to in later videos. Thank you very much for joining me on Miles Maths, and I hope to see you again very soon.